The third form of rounding that we're going to learn is to round to a certain amount of significant figures. What are significant figures? This form of rounding, first of all, is usually used for very big numbers like 65,789 and so on, or very small numbers like 0.00000000000087923. But it can be used to round any number. We need to learn how to count significant figures, or what are significant figures. Significant figures are figures that mean something, that are important for the number. So in a very big number, only the first figures might be important to tell you how big the number is. And when we're talking about a very small number, only the first few numbers that are non-zero figures will be the figures that will tell me something about the number. This is usually used for measurements in real life, such as chemistry elements and things in biology, atoms, cells, and so on. So significant figures are figures that are useful, that will give you information about the number. We count significant figures from left to right, starting on the first non-zero figure. What does this mean? Look at this. We have 0, 0, 0, 0, 0, 0, 0, 0, 0. All those zeros do not count, and we start counting from the first number, or from the first digit that is not 0, right? Here, in this big, huge number, the first digit that is not 0, it's the first digit of the number, right? Because we don't have zeros to the left. So in regular numbers that are not like this, we will start counting from the first digit. Zeros in the middle do count, right? If we did have a 0 figure in the middle, it will count. It's not that we do not count zeros at all. We do not count the zeros that are to the left. We will be asked to round to 2 significant figures, 3 significant figures, and for short, they will give us the shortened SF or S point, F point, and so on. This will help us identify our target. So let's see, how do we identify our target? Because after that, the process is exactly the same as we used to do. Let's see. In this number, we count from left to right, and we start counting significant figures from the first non-zero figure. So the first significant figure is this one. The second significant figure is number 2. 0 will be the third significant figure. Why? Because the zeros in between will count. The first zeros do not count, and when we start counting, we do not stop because there's a 0, right? 0 counts there, so it's the third significant figure. Then we have the fourth significant figure, the fifth, and the sixth. In the case of a regular number, such as 6,789,303, we start counting as usual, as we count from left to right, starting on the first non-zero figure. We have no zeros to the left, so this would be significant figure number 1, significant figure number 2, significant figure number 3, number 4, 5, 6, and 7, right? So let's see what happens if we have to round any of these numbers to 2 significant figures. So the target, if we have to round to 2 significant figures, we said that 9 was the first one and 2 is the second one. So the target will be in our second significant figure. And the procedure is exactly the same as before. As this is my target, I have to look at the number to the right. As the number to the right is smaller than 5, it's 0, this number stays the same. All the zeros belong to the number, right? So we write the rounded version is 0.00092. These zeros do not go away. What happens if I make them go away? I round the number and I give a rounded version as 92. Is it possible that 0.000920345 will round to be 92? It makes no sense. That's what I told you before. The rounded version of a number is a number that is pretty similar to the one we had, but it's simpler, right? It's simpler because it has nothing of this. Let's see what happens with this number. The first significant figure is this one, so the second significant figure will be that one. So now our target is number 7, right? As the target is number 7, we will look at the number to the right and it is an 8, so we have to round up. So this will be 6, 8, and then everything becomes 0. 6,800,000. Let's see some more examples. Let's see some examples. Let's say you have to round number 802.479 to two significant figures. So the first significant figure is number 8, and the second significant figure is the 0 over here. Remember that zeros that are in between, once we started counting significant figures, they also count. So 0 is our target, so we need to look at the number to the right. As the number to the right is smaller than 5, then this will round down, which means the 0 will stay the same. 800.000, or simply 800. Let's see the second example. We have many zeros to the left, so the first significant figure will be number 5, the second one will be number 4, and the third one will be number 8. So our target would be number 8 because we need to round to 3 significant figures. Then we'll look at the number to the right, and the number to the right is a 9, so we have to round up. So our new rounded version will be 0.000000549. Remember that these zeros are vital, right? If we don't write this, we will only write 549, which would be ridiculous. Let's see example number 3. We need to round to 4 significant figures, this huge number. So the first significant figure is this one. The second significant figure is the 0 over there. The third one is number 3, and the fourth one would be number 1. As we need to round to 4 significant figures, our target will be number 1, and we need to look at the number to the right. As the number to the right is smaller than 5, then we round down. We will write 703, and the 1 stays the same, and then we will complete all the number with zeros. We would write either these or 7031000 with no numbers after the decimal dot. These zeros are not useful, so if we write them, it will be correct, but we usually don't. So the number will be this one. Let's see the last example. We have to round this number to 2 significant figures. So this doesn't count, and this doesn't count. But here we start counting. This is the first significant figure, and this is the second significant figure, even if it's a 0. So we will take it into account, and we'll look at the number to the right. As the number to the right is a 5, we need to round up. So this would be 0.0031. And all the zeros that we have afterwards, we don't need to write them. So the rounded version is this one over here. Remember to write the zeros at the beginning. It's not the same if you write 31 because it's a number, it's very far away from 0.0030 and so on. So this is it. You'll have some exercises to practice on the platform.